Welcome back to another exciting video of IncoVid, wherein we redefine engineering and bring in a fresh outlook. Did you know that the entire automobile industry would have to suffer huge losses if this property of fluid was ignored? This is how significant this property is. We were discussing fluid mechanics and we will now explore the various fluid properties that are often used by engineers in designing our day-to-day life. Now, coming back to the initial question, what do you think about that property of fluid which has got huge significance in automotive industry? Got any clues? Yes, it is none other than the viscosity. Viscosity is calculated for all the fluid-dependent functioning used in your vehicles, from brake fluids to lubrication to your engine fuel. Even seen the engine oil, which has a specification starting such as 5W to 30. It is nothing but the viscosity index of the particular oil. Now we will see what exactly is viscosity and how is it an important factor in engineering design. Viscosity is simply the resistance to the fluid flow. When a stress or a force is applied on an upper layer of a fluid, the lower layer will slow down this flow and hence causing a deformation. Have you ever tried rowing a boat across a water body? It is a difficult task as the water is applying viscous force on the row. Now imagine rowing the same boat on a lake filled with honey. You might have to apply twice or thrice the effort to row the boat. Now, back to the reality. The fluid layer concept could be easily understood by a simple example of deck of cards. Have you tried sliding your hand over a deck of cards? The card on the top will move the most, along with your hands, and the subsequent cards gets moved relative to each other, and the card on the bottom never moves. In fluid mechanics, these cards are the fluid layers that we discussed earlier. It was the great physicist Sir Isaac Newton who postulated a law for this, which is called the Newton's law of viscosity. He calculated that this shear stress is directly proportional to the difference in the relative velocity between the layers to the distance between each layers. The constant of proportionality is the measure of viscosity. It is measured by the engineers using viscometers and rheometers. All these meters use one principle, that is, viscosity of liquids decrease with the increase in temperature. The application of knowing viscosity is immense as it is used by the engineers worldwide in petroleum industry, cosmetics, construction, food industry, and even in artistry. However, the most important application of viscosity is in maintaining vehicle efficiency. Ships use a viscosity controller, most commonly known as viscotherm, to heat the fuel before it is injected the engine cylinder. Had the fuel not been heated, the oil would have passed in through the injector with a high viscosity and causing incomplete combustion and huge loss of fuel and hence huge loss of marine industry. We will explore the other important properties in upcoming videos and will unravel how important is fluid mechanics in our day-to-day life. Before we go, we have an interesting fact about viscosity. Ever had a bad cough and doctor recommended you a cough syrup and within hours it got cured? Cough syrups has a high viscosity which is designed in such a way that it is drinkable, and once it is reaches your throat, it creates a coating over your throat, creating a protective layer in case of an infection. What a genius idea, isn't it? If you had liked to be a part of this community, please subscribe as we have loads in store just for you in your upcoming videos.